Okay, YouTube, this is my sixth video on solving trig equations in which we're going to confront an instance where we have just one trig function. So, like, congratulations to us. But we have a coefficient to our angle variable in here. That is, we have a multiple angle. So we're going to solve this just like we would as if that had said, 2 cosine t minus 1 equals 0. We would start by isolating the cosine function, then undoing it with an inverse trig function. But this is going to require that we build in an extra step when we solve this one, okay? So what we're going to do is we're going to say, all right, well, first of all, let's isolate our cosine value. That is, we're going to boot the 1 to the other side and divide by 2. And so for the sake of time here, I'm going to go pretty quickly. We say cosine 3t would equal to, add 1 divided by 2 would be equal to a half. And now that we have this trig function isolated, we're going to undo it using an inverse trig function, okay? So we say inverse trig function here. Whoops, let's change colors. We'll do an inverse cosine and r cosine of both sides. Our cosine. And so we get this. We really get 3t instead of just a t. And in this case, we get it equals to cosine inverse of a half. That is, 3 times our angle is equal to the angle that you get when you took the cosine of it and you got a half for an output. So we say, well, first of all, what must have been the output, or sorry, the angle, the reference angle, if you got a cosine value of a half? And so we'd say, well, in the reference angle, the ref angle, I'm going to write it this way this time. So it'd be like 3t prime, but I'm going to write it this way. We say it must have been a pi thirds reference angle. And I'm just going to go, and we could even refer to our unit circle in this case. We say, just to be quick on this one, what are the angles that give us a cosine value of a half between 0 and 2 pi? So I notice that it again, is this pi thirds reference angle here. And so we'd say, okay, well, pi thirds reference angle, cosine value is a positive a half. So we must be in the first or the fourth quadrant. And we would just go sketch in a pi thirds reference angle here and a pi thirds reference angle here, and we'd ask, well, what are these two angles in standard position? So here's one, and here's the other one right here. And again, we could say, just verifying this with our unit circle here, we'd say that one is pi thirds, and the other one is going all the way around and getting down to here. This is 5 pi thirds. So what happens in this particular instance is this is what we have to do is we have to set it equal to both pi thirds and 5 pi thirds. And not only that, we have to say, well, we have to add on multiples of the period of the cosine function. So we say cosine has a period of 2 pi. We say 2 pi n onto both of these. The idea is that this is what 3t equals in either case, but what we are after is t. So just like every other problem, we in the past we've stopped here. What we're going to have to do is we're going to have to isolate t just by dividing everything by 3. Okay. So we have to divide both sides by 3. This means we have to divide everything on the right by 3. So what this basically implies then is this. We get in this first equation, we say a third of pi thirds is a pi ninth. You could, if you want to review on your algebra here, this divided by 3 is the same thing as pi thirds times 1/3. Okay, so multiply by the reciprocal, but we get pi ninths. And then this 2 pi n over 3, what we usually do is just a kind of a good idea is you just put the 2 pi part over 3 and we'll just shove the n off on the side, where this is just multiples of this amount right here. And then down here on the bottom we say, well, 5 pi thirds divided by 3, that'd be 5 pi ninths. Okay, a third of a third is a ninth. And we say plus 2 pi thirds n. So I can make you a promise, this part right here, these should be identical. But these are our solution values. These are the solutions. And what I would like to do is also just go verify this graphically. If we were to take this equation where I've graphed 2 cosine 3t minus 1 and say, well, what are the zeros of this equation? Where does it equal 0? I've already done this. You can see that really what happened when we said cosine of 3t was we were tripling the number of cycles it goes through in a normal 2 pi period. You can see from 0 to 2 pi here it goes through 3 cycles. So what we did was we solved for the initial two, this pi ninths and this 5 pi ninths. Again, I can just say these are these two angles here. And then what we're doing is we're adding on 2 pi third increments. So instead of adding on a full period times n, or multiples of a full period, we're adding on a third of that because it's only taking a third of the amount of time to go through the full cycle. So for instance here, we'd say if I added on 2 pi thirds to pi ninths, I would land at 11 pi ninths. And if I added 2 pi thirds onto that, I'd land back here again and again and again. So the difference between solving an equation that has multiple angles and a single angle is that once you've found your solution angles, this here and this here, you still need to isolate for a single angle by dividing by whatever its coefficient is, or what we lovingly call the b value when we talk about graphing. Cheers.